So we'll okay. So thanks everyone. Thanks for taking time today. So we will start with one session. Are you able to see my screen?
Yes, we can see your screen.
All right. Okay. Thank you. So basically today, we will cover about especially microservices. Like, there will be a session about microservices, how we can use microservices, and what basically are microservices, and key aspects of that. Then followed up by, how we can make them a little more observable, and the whole new idea of this observability. Right. So basically today's session is a little bit of a theory, but we will try to touch upon a couple of AWS services, which will add which will be important when you are starting. You start monitoring and observing your infrastructure, the application systems, right? So, and especially when you are running with Kubernetes, because Kubernetes require a little bit of babysitting and observing, and ensuring that we have close attention. So this topic will be, I'm pretty sure, like, for all of you, a very new topic, because I know that you might have done the software development, system development and all, but I'm not too sure you had experience in monitoring, right? Because probably at your level you would have not uh, there would have not been any requirement for you to monitor any system or application or site or anything, right? But when we are moving from the standard the development and creating products which will be used by end users, then the observability or the monitoring is very important, right? So whatever we, end of the day, idea is that whatever we deploy, whatever we develop, we'll have to deploy, right, in production environment, and that will uh, the app systems or the application will be used by end users, right? So end users will have a lot of issues, right? So they can have functional issues, they will hit software bugs, there can be infrastructure issues. So, like, we have a kind of a theme in software development, software consultancy, and everywhere. So end of the day, customer experience is the king, right? So just like, like probably you would have heard this, like, customer is the king. Just like that, now world has moved into a even little further. It's not only customer but their experience, right? What they are getting out of our system. Our systems are able to provide that world class services they are expecting, is the most important thing, right? So basically the customer experience is the most important thing. So the systems we have developed, deployed in AWS, and probably we are trying to make things microservices, so that we can decouple a lot of dependencies, and probably using Kubernetes. So all of this, these things is still, we need to monitor and observe, right? So actually, like long time, right? For a long period of time, probably couple of decades, monitoring is the important thing, right? So when it comes to we deploy something into production, people will always say we have to monitor. Now it's getting changed. So we are moving to more for observability as the main requirement. So, but without discussing about monitoring, you will not have understanding of what observability. So I'll try to touch upon very quickly what is monitoring, and then start discussing few fundamentals about observability. Right. So monitoring is when you deploy, example, when you deploy application in AWS, right? Probably you might have your EC2s, right? So we will have EC2s. Let's say infrastructure is based on EC2s, and then we will on top of that we will have a Kubernetes, and then we have deploy microservices, and there can be other various softwares, right? We have deployed in EC2s, like example middlewares, databases. We can be either deploy our own database, or maybe we can use AWS RDS or a document DB, or any such other AWS provided services. We can be either using the Kafka, we deploy as service, or we use AWS provided the MQ service as well, or we can have NFS, CMS, or any other software, right? Generally, we can generalize it as softwares, right? So then if it is a Java based, it can be JVM. Then otherwise it can be a .NET driven, like .NET framework as well. Then so this is like your infrastructure and application. After that, your user journeys, right? So what example, if you have deploy a ordering application where a user comes and go through products and then select product, add them into a shopping cart, and then do a checkout and do a payment using credit card. So those are user journeys, right? So user journeys are the other key important thing. And then each application will depend on upstreams and downstreams, right? So probably you create an application where user login is based on like Google authentication, right? So they, or Twitter, or GitHub, right? So now if those systems are having issue, then our system will have issue as well, right? So upstreams and downstreams are key components of our ecosystem, right? So very high level, these are the key areas, right? So example, when you look at infrastructure, EC2s, you will have to check whether EC2 is up and running. You will have to check with the CPU memory file system, because any of these issue will have a ripple impact, right? That will bring down your EC2, that will have impact on your end user experience. Example, Kubernetes, you'll have to check whether masters available, worker nodes available, kubelet and kubelet process, Docker, and all those resources, all those memory and those things are available, because like especially in Kubernetes, one of the main issue is memory, right? So unless we monitor, there can be issues where those issues can result in your pods getting restarted, and you will have lot of issues, right? And microservices, like so microservices are a small piece of code, which is deployed separately, which is serving a particular business problem, right? So then you'll have to check whether that microservice is available, right? And then whether it's performing as expected, whether there are any exceptions, right? So that is very important. And then example, the microservice, the business purpose, right? Assume that you have a microservice which is just checking um, example, let's say that we enter centigrade and it's doing a conversion of Fahrenheit, right? So we'll have to check whether that microservice is performing as per the need, right? It's doing that conversion probably, like a simple example, right? So that is what the business monitoring, right? So any microservices, you'll have to understand business need and then you start monitoring, right? So any software, you'll have to check the availability, performance, exception, right? And JVM and all their utilization, user journeys, probably we can use synthetic monitoring, interfaces available, heartbeat. So what the summary of this is that there are a lot of infrastructure monitoring we had to do, there are a lot of application monitoring we had to do, there are a lot of what you call software level monitoring we had to do, there are a lot of interface level monitoring we had to do, and the user journeys, right? So all of this will allow us to come up with a good monitoring framework for our application, right? Even like in another session, we will check this demo application, right? The POC we are doing, we are going to integrate example Prometheus and with Grafana, and if possible ELK stack, and then that will allow us to monitor, right, our application, right? So if someone asks you why are we monitoring, because customer experience, right? So example, if our application is down, customers will have a bad experience, they will go for competitor. Our application is having a sluggish performance, customers will get tired, they will move to a new competitor. If our application is having errors, right, when they are going through, they will go to a new competitor. Right? If our application is not secure enough, right, HTTPS, but instead of we have HTTP credit card payments, they will not use it, right? So basically, just having a good business idea and coming up with a good website or system is not enough, right? You'll have to provide that customer experience, otherwise users will disappear, right? So very simple terms, this is monitoring, right? So monitoring is nothing but checking your temperature, right? So you feel like you are having fever, and then you get a thermometer and you check your body temperature, and you might get a 98.5 or 99.9 or something, or 101, right? Sometimes we say, oh, we have more than 100 temperature, right? So monitoring is always we have to predefine something, right? We have to tell what is good. Example, CPU. We say CPU below 85% good, and CPU above 85% bad, right? Temperature below 98.5, okay, right, good. But temperature gone beyond 98.5, bad, right? So we are telling we have fever, right? So what the issue with the monitoring, right? Like monitoring is like, been there for ages, right? And that is the most important thing, right? Just ensuring that like, our applications are run up and running, right? Just like our human body, we need to monitor our the softwares, the systems we have developed, we have to monitor as well, right? So now in our human body, we have to, example, I feel like I have fever, I have to check the temperature, right? So then that will show me that, I have a, like, slightly higher temperature, right? And probably, like, maybe you have a IoT device, where some wearable, where that can keep on continuously monitor your temperature and send you alert, right? Okay, looks like your body temperature is high, so you are having fever, right? So when it comes to monitoring, that is similar to what we are doing for systems as well, right? So we will define what to monitor: your CPU, memory, file system, right? File system, C drive. We'll say, if it is below 95%, that's fine. But if it is above 95, that will have an issue, right? That will create a volatility. Our application can come down or encounter some performance issues, right? So example, just like, the body pressure, right? So you will get a equipment, you will check the pressure of your body, and you will say, like, 80 to 120, it's good, right? I'm managing my body pressure, right? Probably, you are a diabetic person, so that, take your blood and you, like, do a fasting blood sugar or something, and you will say, okay, it's below 120, it's good, but above 200, 120 to 200, fine, but above 200 is little bit of unhealthy, right? There's a risk, right? So basically, one issue with monitoring is that it is always a predefined thing, right? Someone has to come and define what is good, right? Example, you take any metric, you'll have to define what is good, and then this tool or something will keep on monitoring that, and if it breach that, what we have defined as what is good, it will come and alert us, right? So that is basically what is monitoring, right? So now the world is moving from monitoring to observability, right? So we want to observe things, right? So the disadvantage is that, so example, like, very recently, I know one of like, one of my friends, like, I know a person, right? Who died of a heart attack, right? So who died from a heart attack, right? And when they took him to the hospital, and then he was passed away, they have done autopsy, and they are saying, like, in his heart, three of the valves are blocked, right? Three of the valves are blocked, right? And we have this, like, modern technology, we have everything, and but people is still dying with heart attack, and they find that, valves are blocked, right? Probably, so the problem is that, probably how we monitor is not correct, right? So probably how we are monitoring is, we are probably, that person, someone would have asked to get a report, right? And probably that report is at a higher end, right? And then higher end, probably someone would have assumed that, that's fine, right? Right. And probably that person had a, like, probably he would have felt like, there's a pain in his left arm, but he thought that it's just a random thing and not bother to tell anyone, right? And probably doctors didn't thought that, um, he should not go through, maybe his ECG was fine, right? Nobody thought that doing NGO is good, right? NGO is like, you put like a small tube and then from there you put a dye, and then the doctors can see in camera, like, what are the block valves, right? So we understand that when it comes to systems, even now human body, monitoring is not good enough, right? Monitor, so example, assume that, you like, when you were kids, right? You go and tell your parents, I feel like, I'm having temperature, and then only they will check your uh, temperature, right? No, otherwise, they will all probably, if they feel like, when they put their hand into your head, they feel like, there's a high temperature, right? Probably then only they will check, right? So we usually do monitoring when something start failing. But example, when a user report that I'm not able to access my application, we would have got the monitoring alert 5 minutes back saying app is down, right? So when someone is saying I'm having a slow performance in my application, same time we would have got a alert for EC2 saying EC2 is running with the high CPU, about 95% CPU, right? So it's a very, so at that time, the what else to do, right? So you had a heart attack, you put a patient into the hospital bed, and you do NGA, and you realize that all the like 4 or 5 valves are blocked. What to do, right? It's you are in last stage, right? But what we want is identified issues little early, so that we can be more proactive, right? So if the customer experience is the most important thing, we should not wait until customer report, right? So we should have proactive monitoring, right? But proactive monitoring is again, example, now you would have said, okay, now we think that about 95% CPU is bad, but we'll get alert at 85. So we are getting something little early, right? So that's a good argument. But the problem is that then probably 85 to 95 it can happen in very short time. Otherwise, even if you get a 85 alert at 85, and you will ask, okay, the person who is looking at it and say, okay, we can work until 95 good, he will just not take it seriously, right? He might not able to correlate, right? So problem is that this threshold driven alerting or monitoring is not good enough, right? So that's why we thought of the industry moving toward this observability, right? So idea is that go beyond this traditional monitoring to observe things, right? So one of the good example I can give you is, if you have ever been to ICU, right? If you have seen an ICU patient, right? So ICU, when the doctors put a patient to ICU, they put all the gadgets, right? All the gadgets are there, right? They will put couple of plasters in your chest, and they will see a running ECG, right? You see your heart is going up and down, up and down. In the movies you have seen, right? And then they will check the pressure, right? You can see your pressure like in a real time. They will check your oxygen saturation, right? Above 95 or something, they will check that, right? That is there. And then probably they will put few other gadgets, and we start monitoring other as well, right? So now what is doing, not that if something happens and you feel like you are not able to breathe, someone comes and put a oximeter and check your the oxygen saturation level, but real time now it's getting checked, right? So they are observing, right? So now when we are observing, it gives us clue, right? So example, we see that oxygen saturation level is a little high, right? The ECG also showing little weird behavior patterns from the heart. We feel like okay, this patient is a risk of having a heart attack, something. Probably someone can correlate that, right? So then they can give, right, probably some drugs, like example, if the usually when a person is at a risk of what you call a heart attack, they give drugs to avoid the blood clots, right? Right, so they can do some things proactively, right? And the doctors are more in control, right? So they can so do little things more, right? So that's the basic idea of observability, right? So we want, instead of just threshold based monitoring, we want to observe things, right? So we observe things and we have idea what's happening in our systems, so that we take good decisions, right? So example, assume that there was one day your application got crashed, right? So when you are crashing, you look at the data, you identify 30 minutes to the time where the application got crashed. How was the CPU and memory of your EC2 instance getting behave? How was your Kubernetes, ports memory got behave? What were the exceptions you have seen in the system, right? How was that other parameters, right? How was the page loading time, all those things, right? So all of this data you put it into a database, and on top of that you create a AI model, right? And then you feed live data. What it can does is probably now that it has a lot of observing power, it can check whether any given time whether I am in a path of application coming down, right? Because it can correlate all the data and give kind of a educated prediction, right? So observability allow us to do that, right? So example, people who are wearing the IoT devices in their arms, like, the people go to such an extent that, some people are trying to observe their body when they are sleeping, right? So they want to know that whether they went to a deep sleep, or whether what kind of sleep level they had, right? Whether what kind of the brain state, right, when they were sleeping. Some they don't want to just feel good, right? Wake up in the morning and felt, okay, I had a good nap or sleep. They want to check it from a scientific way whether they had a good sleep, right? So they are controlling all those things, right? So that is basically observing, right, in simple terms. So observability and monitoring, I think you already got the picture, right? So monitoring is, we look at predefined parameters and just to understand whether the system is in good or bad, right? Probably you take a full blood count and, you'll check your white blood cells, the red blood cells and other things. And based on the threshold, you are checking whether you are good or bad, right? What you feel, right? But you are observability is, you plug yourself into oximeter, and then you are real time monitoring your oxygen saturation level, right? You are real time getting your blood pressure, right? Your pulse, right? Your heart beat, right? So then you are observing, right? Just like that, we can observe our systems, right? So that whenever we can check whether it's in a path of a non disaster, whether what's happening, and we can take a lot of precautions, right? So that's the main advantage. So that's why the world is moving away from monitoring to more of observability driven, right? Nowadays there are job titles like observability engineers, observability leads, setting up. So observability is like, one branch of DevOps. So now even the site reliability engineering, one branch, right? Okay, so just to again summarize, so like there are a couple of differences, right? So monitoring is defined on the predefined metrics and thresholds, where observability is, trying to get all the data, and so we can observe the system, right? So I forgot to put this, right? But if you have seen like in like example North Pole, close to North Pole, if you have seen a ice mountain in a sea, right? So you see ice mountain, but there's a lot inside the water as well, right? So people usually say just by looking at a ice mountain, floating in the water, you can't judge its size or power, because majority of the things are inside the water, right? So that is why the observing is important, right? So we call monitoring proactive as well. So we are telling proactive monitoring. We kind of like come up with maturity models and all. But if you are looking at monitoring, is always you get alert when your predefined threshold is breached, right? So there are numerous times we have been where we have not defined. So monitoring is always you have to define something, right? Unless you define, you can't monitor, right? But observability is more of like, you are observing your body or your system, like you are allowing all the data to come, right? And then you are making analysis, data analysis and AI ML, like, and you are making those decisions, right? So it's more of a proactive now, right? So probably monitoring is now going towards more of a reactive approach, where observability is the more closer to proactive, right? So an observability allow us to explore, debug, right? So in our microservice we have issue, we can go and observe, right? And we can go and explore, we can go and debug, right? So that is the most important thing, which observability is bringing in, right? So this is a very quick course, right? We are not going to do a lot of aspects, but just I want to give you a feel of what is observability and what that means, so that when you are starting microservices, you feel like, what are the important things, right? So it's not that, you will learn microservices and try to make it observable, but from the initial, the design itself, you will have that idea that when you are writing code, you have to make it observable, right? It's not that, reverse engineering, right? You write something and you try to make it observable, but the best practice is from the time where you are writing something, you try to make it observable, right? So key pillars of observability: logs, right? So if you are writing application, your application has to have logs, right? So it can have different type of logs, right? It can be a debug log, right? So you print on everything. So example, a method get called, you write something into a log. Starting of the method processing, in between processing is complete. So everything you write into a log, all the errors, everything, right? But that is expensive, right? So that can sometimes slow down your application, right? So instead of debug, the next level is you can go to the, let's say, warning, right? So then all the warnings will be included here. But sometimes warning is also too much. You can go to the next level, which can be error, right? So only the errors are getting print, right? So logs will allow you to understand what's happened. You can able to debug. You can able to go in an audit trail. So that is very important, right? So next one is your metrics, right? Metrics is all the parameters and measurable things, right? Metric can be your CPU, memory, file system, or any other thresholds, like, example, number of page hits, number of page rendering time, page response times, anything, right? So anything, like, again, anything which we can measure, we can, start. We can call it a metric. So that is the important thing, right? So you have to have, so metrics can come up from your infrastructure, application, network, the firewalls, upstreams, downstreams, right? So anything, right? And then your traces, right? So trace is like, we should be able to, so now probably you have understood, most of our systems are complex, right? You have upstream, downstreams, and those are more or less very distributed systems. So when a request comes in, request can get served from, you know after multiple application is passed, right, in downstream, right? So distributed tracing, right, the request tracking is very important. Tracing is, we are able to track the request from end to end, from the time where it created, when it comes to our front end, when the front end codes get rendered, and from there it goes to our business logic. It passed different functions, methods, and it goes to a remote system. From there again, it's passed to different systems. It goes to a database call. From there again, it passed to another system. So all of these things we should be able to trace, right? Otherwise what will happen is, if some issue happens, we are able to look at from what is with system A, but we are not able to drill down, correlate to system B, or correlate to database, right? From the business logic to database performance, we are not able to do that, right? From our application to the other downstream application, probably we are not able to correlate, right? So key things, very high level, remember that this is the key pillars of observability: the logs are very important to monitor, and metrics, right? So metrics are very important, and traces, right? So those are the three things. So benefits of observability, that allow us to, more, be proactive. So that is the very important thing. We can be very proactive. We can understand the faster troubleshooting, right? We can detect things very quickly, and we can troubleshoot things very quickly, and then we can, fix things quickly, right? So if you are at home, you are trying to understand whether you have a breathing problem, against you are at ICU with all the gadgets plug into your body, and then it's more of observability, right? The doctors will know whether you are on path to a breathing problem, or, you are okay, right? So the all are fast detection, fast troubleshooting, fast fixing, right? And that will improve our systems greatly, right? So those are the key benefits when it comes to observability, right? So when it comes to observability, AWS provide quite a few services. So one thing is AWS CloudWatch, right? So you have a AWS account, go and check. So CloudWatch is the go-to thing, right? It has, so example, in our any service, it has this free CloudWatch, which is kind of like getting monitoring metrics every 5 minutes. But you can pay and get a paid version, which will have every 1 minute monitoring. So cloud which will cover, collect data, logs, metrics, event analysis. So it's kind of like the the oracle of everything, right? So it oracle of observability, right? It will start observing entire AWS and in a holistic manner, so that you can identify what's happening with the infrastructure resources to any other thing, right? So all there are a lot of integrations, and there are a lot of plugins where you can go and integrate with CloudWatch, so that can again give you the better service. So CloudWatch alerts with SNS, the simple notification service. You can integrate with email and SMS alerts as well, so that whenever something is getting broken, something is not working, metric is breaching, you can get alert, right? So then there's something called AWS X-Ray, which is again provide end-to-end tracing, especially when it comes to distributed application, especially if you are using microservices. That is a very important service you should use. So X-Ray has a lot of benefits, especially when it comes to distributed systems, when it comes to you want to trace your request from front end to the business logic and the method level and to the database. So that will add lot of capabilities to your observability platform. So one other thing is, just remember that it has a distributed the capability, so that it is able to track all the distributed requests going through, right? So CloudTrail is again, all the API related activity happening within your account, it can check, right? So it will log in, so that you can, you can again, CloudTrail logs, we can pass it to CloudWatch. That will allow us to, monitor, right? So that's again, you can pass these things into CloudWatch and get CloudWatch to, come like do the aggregator and alerting as well, right? So CloudTrail is very important tool, which, which will track your API activity and visibility of AWS resources usage and provisioning and those things, right? So if you are using serverless AWS Lambda, then Lambda insights are very important. That will give you idea of how it's behaving. And then probably you would have heard of something called ELK, which is stand for Elasticsearch, Elastic, Logstash, and Kibana. So that is kind of a log analytic tools. So AWS have kind of a very similar stack, which is known as the OpenSearch. So OpenSearch will again allow us to observe our application business and all those parameters, especially logs and metrics and traces, right? So these are key tools, right? Like go and check your AWS CloudWatch, X-Ray, CloudTrail. So those are three things, right? Especially like so this course we are not going into Lambda. They are not going to touch about serverless. So these are the top three is the important thing, and we will do some little bit of ELK as well, so that you will get an understanding, right? So what are the best practices, right? So in observability, some of the best practices are, first you will have to understand what is relevant to you, right? Just because we have so many medical reports, health checks, we are not going to get everything, right? So it has to be meaningful, and it has to be aligned to what is our requirement, right? So example, you go to a doctor will not prescribe all the health checks. So you have to understand what is relevant, right? Next one is something called instrumentation, right? So that word, remember that, right? Instrumentation, right? So that is about adding code, right? People will say instrument the code, right? Because the code level you will have to write things in a proper way. Otherwise, this observability you can't achieve, right? If you don't have logs, then observability, it's a handicap, right? So the instrumentation, properly writing codes in your application is a very key thing, right? And then centralized login aggregation, that's again a very important thing. And the automated, right? Automated alerts, right? So observability is good, but it had to have alert, right? So example, if you are, if you have any elder person at your home, that, usually people above 60 or 70, especially 70, right? 70 or 80, they fall, right? The falling is very common thing, right? So now there are a lot of wearables, right? Wearables, we can get our parents to wear, or grandparents, where if there's a fall, it will detect that there's a fall, and then it will send a alert, right? So example, you are like especially in some foreign countries, so most of the people, live sometimes alone, right? Not with their family and their children. So sometimes, they have this, services. Yeah, they can buy these IoT devices, and then devices will start feeding data to centralized place. And from there, if the person got fall down, the it will go to the command center, and command center will able to arrange the ambulance even, right? It will send the ambulance even before anyone get to know that someone has fallen down, and the ambulances will be there within 5-10 minutes, right? And based on all the data, probably they are able to predict that someone might be fell as well, right? Because they have seen, now example, my father, right? I know he sometimes, we don't have these devices, right? So even though I was trying to buy something, so he has the ability, at least once a month, once a month, or couple of times a month, he get fail, right? And sometimes he get injured his forehead, and we have to get the stitches and other things. So but I know based on now his behavior, so when he sat in his bed, if he try to get up quickly, there's a high chance he will fail, right? Because he will sometimes lose the balance, he will try to go little backward, right? But if he's so that usually happens, he's excited with something, right? He's excited that probably because he wants to get the drugs quickly, he might be excited thinking anything, right? The old age people get excited, and and then they start little bit of shivering and all those things. And example, I'm assuming that there's this device, and this device being in other part of the world, right? When people are wearing those collected data, probably the device can make intelligent guess that person is in a little bit of excited situation, right? And and he has person has tried to get up quickly, had little bit of falling scenarios, and probably risk of have a fail down, right? Probably that this can send a alert to some person close by to go and visit and check, right? Or probably send a alert to that person itself saying, okay, feel like and let's assume that orange color bulb getting beep, right? So the person knows that okay, this means that I have to calm down, I have to sit in my bed, not to get up, right? So those are kind of like what we are, I mean, those are things which is we observe how we are observing our human body. But the same philosophy, same theories, same concepts, we are applying into the systems, right? Sometimes systems are as good as identical as our human body, right? So the alerting is a very important thing. And then obviously we'll have to do the continuous improvement, right? Okay, so this is a kind of a session, right? And I know that it might be little tiring for you, but the key message is I want to give you that there's something called monitoring, right? So we had to monitor our bodies, and we have to monitor our systems. And just like our monitoring of our body is not good enough, we have to monitor, observe our uh, systems, right? Because monitoring has its the disadvantages, especially because it's threshold based, right? So when you are observing, the key pillars of observing is the logs, metrics, and traces, right? You have to have logs. Your application has to be defined. A microservice has to write in such a way that it write all the errors and other important things into logs. You have to have metrics, able to extract the metric and start monitoring. And then traces, right? So you have to have your code instrumentation in such a way, using things like Zipkin or OpenTelemetry. You are able to trace, right? Create traces for your application for distributed request tracing, right? So AWS support things like CloudWatch, X-Ray, and other things, right? And we discuss about the other slide, what are the key things we should monitor. Things are like CPU, memory, file system, infrastructure, Kubernetes, availability, exceptions, any software exceptions, availability, performance, latency, and the JVM and those kind of things, the user journey, synthetic monitoring, and all those things. So idea is that we should get alert even before our end user realize that there's issue, right? We should get alert that I will get a heart attack in 2 days time, not that you have a heart attack. I should get alert saying you will, my father will in a risk of failing in 5 or 10 minutes time, instead of alerting he is already fallen, right? So that is where we want to be, and that is why we are moving to observability. We want to know system will fail early, not that alert saying system is already down, right? So that's why we are moving to observability concept. And if you look at AWS service like Route 53, ELB, EC2, RDS, US3, VPC, Lambda, the container service like ECS, EKS, Fargate, and the Dynamo database, APIs. So almost everything is being watched by CloudWatch, right? So as I said, CloudWatch is kind of like Oracle of monitoring or observability. So you should be familiar of CloudWatch, right? Go to CloudWatch, check whether what data available if the EC2 is up and running, so you can have that understanding. Next important thing is your CloudTrail. So that is like API tracking, right? So whatever the API related calls which has happened related to system, AWS system, that will capture, that will give you kind of a good understanding the inner workings of AWS, right? And AWS X-ray, which covers most of these areas as well. That is the key thing we should use to distributed request tracing, right? So Amazon S3, Route 53, the resolver we can monitor. VPC flow log is the network related flow logs, that VPC flow logs again we can feed into CloudWatch, and then we can ask CloudWatch to start monitoring. So there are tools like Amazon Inspector, AWS config, and all those things. So these are the key things, right? So we are not going to the details of these things, but this will allow you to having knowledge of these things will allow you to come up with a comprehensive observability setup for your application, right? With that, any questions from anyone? Okay, so I know that it's a little bit of theory, and probably you might feel a little bored in a Sunday evening as well. But the key message I want to do is don't worry about all the aspects, but understand there's something called monitoring. Observability is always better than monitoring, and observability is nothing but your logs, metrics, and traces. And when it comes to AWS CloudWatch, X-Ray, and other key services are the key important things, and you should have a good understanding of CloudWatch, right? CloudWatch is a kind of like the oracle of observability or monitoring. So that will give you a quick idea, like how to observe your system, right? So with that, if there are no questions, I'll pass this to Kapil and Mohan to take it up and go with these other sessions. So one other thing, we want to tell you is that, I know that, roughly around 20 to 30 people are joining. So we are planning, working with the computer society and to give a certificate, right? Probably a certificate we are trying to check the possibility of giving the certificate from Workshar's side, so that we can give you a Workshar certified certificate saying you guys have participated a DevOps training conducted by us, and that will give you kind of value into your CV and to your overall to appreciate you spending this time as well. So basically what we are thinking is that we will check the participation, because participating key, right? So everyone who has participated, we will try to ensure that those everyone get more chances of getting this certification. And also we are trying to check whether what other the areas we can so it's just like we'll try to ensure it's not monitoring, we're going to monitor and give you the certificate, but we'll try to observe, right? And encourage and appreciate everyone who turn up, who took time to share their view, who was engaged, and consider all those things when we are giving that certification, right? So that's the message we will to give you. So your participation we'll try to appreciate in some way, right? So unless if you don't have any question, Kapila, you want to take it up?
Sure, Indika. Yeah, just to add, like, not only the participation, right, Indika? It should be like active participation. So we must highlight that active part, right? So, I mean, So so at the end, you should be like configure these environments, and you should be able to demonstrate what you have learned throughout the program, right, Indika?
Yes, absolutely. Yes. So probably, like, we might have kind of we'll ask you to do a presentation, right? Presentation of your POC. We'll ask you a couple of questions. So our whole idea is that to validate that, how best you have used these sessions, right? And don't think that, you don't need it, or like, we will skip that one, but we'll try to make sure that that is kind of like a little bit of a value added certificate as well, so that it can demonstrate your capability into DevOps.
Yes, exactly.
I have make you the host, Kapil.
Sure. I'm sharing my screen. So hope my screen is visible. So basically today we are going to discuss about microservice architecture, and also during last session Indika explain you what is monitoring and observability. And before we start today's sessions, I just want to like recap what you have like learn what you have covered during last few sessions. So hope you remember this diagram. Okay, so this is what we are going to achieve at the end of the program. So yeah, this part actually we have already covered, right? I hope so everyone has created AWS account, and everyone has configured 3-node cluster, Kubernetes cluster in your AWS environment. And today so we'll be focusing on this part basically, that is our microservice, the application that we're going to deploy into this like Kubernetes environment through our CI/CD pipelines. And also so we have already discussed the observability part. So basically just want to like during today, like we will be covering like mainly theory. I mean, we have already covered theory part, observability, but I will show you how we have like implemented observability in the microservice application that we have developed. And that is the current basically the status, I mean the journey so far. And so before I move into microservices, I just want to like explain, like talk about the software architecture. Right? Basically, if you take about, I mean, if you take our house, like so we need to like basically design the structure of house, like how many columns are there, how many beams are there. Likewise, we have to like basically structure our home, right, before we go into actual constructions, right? So in same theory applies for system as well. If you before we implement any code or any system, so we have to basically design. So we have to like understand what are the key components we should have, and what are the basically the relationship between each components, and how we have to like interact with each other. So those things we have to like focus, and that is we call software architect. And if you like so I mean when you like design or discuss and design all these things, so you have to consider like the business strategy, obviously the business benefits that you're going to achieve using your system, and also the quality attributes, human dynamics, and as well as the design, and also your IT basically environment infrastructure. So considering all these factors, I mean you need to consider all these factors when you design or your architecture of this application, right? And so there are actually several different architecture styles you can find, but I just highlight actually commonly few architecture style here. Those are like common architecture styles. So one is multi-tier, and so basically multi-tier is like I think we discussed this last few, during our previous sessions as well. It's basically in the architecture you can find several tiers, like the data tier and the business tier, the front end likewise. So in this case you can find yes, basically client server architecture, and it's multi-tier. And also the monolithic application is another style you can find actually commonly in the IT industry in the software application. So those are basically kind of like all in one application. For example, data and your business logic and your front end, it will be in one layer. So those are called actually monolithic, and as well as we can find another architecture called layered architecture, and it's basically so similar to NTR, but it's different. Like in layered architecture you can find several layers, and each layer will have a specific role to perform, and as well as one of the common architecture is database or a data centered architecture. Here actually the whole application will will be basically based on their data resources, repositories, like data sources. And obviously last one is microservice architecture that we are going to discuss in detail during next couple of slides. Yeah. So before moving to microservices, I just want to touch the common pain points that you face if you're using monolithic, or if you're using old application style. So these are the few common pain points that you might face. So one is too complex because since we are putting everything in a single application, all the data, databases, business logic, and everything will be in one layer. So it will be a bit complex to manage, and as well as like too slow, because since your data layer and the business logic will be in same application, same container, it will basically impact your performance, right? And also too fragile. So if some component or the small application, the part of program fails, it might impact your entire application. And as well as no specification. So basically since we have a huge application is running, so it's hard to basically manage your CPU and memory and all this. And also since we are basically 1 minute, 1 second. Sorry, sir. Okay, so yeah, we were talking about no ownership. So since we are have a one application, so and every code will be in one project, it's difficult to manage, right? So entire team, someone might take do some changes into code level, and then some in different days, like if someone comes to Playline, he might do some other changes into the same code base. So it's really difficult to find ownerships, right? And as well as testing, it's really difficult. If you want to do system testing, unit testing, really difficult, since we have everything in one. But as a solution for this the pain points, so microservice comes into play. So this is the definition that I had taken from the net. So I just want to highlight a few things. So in as you can see here, so in microservices architecture, so basically we are like trying to break the logic, the single application into different components, different small services, right? So and as well as so those the small services will be running on their own processes. Their own, actually, the containers might be the processes, and also the communication in between these services will be lightweight. Those are the key things that we can actually understand, like identify in this microservices architecture. And as you can see, build around business capabilities and independently deployable by fully automated deployment machine. So these services are basically, can be built, deploy independently without having any, any inter connection. So you can simply, if you have two microservices running, you can simply deploy single one microservices without impacting other. So as you can see in this diagram, actually, here we have a couple of microservices, and also these are the basically platforms like you can use load balancing, monitoring, health, provisioning, so and also service discovery. So we are going to talk about benefits of these microservices. One is scalability. For example, let's say so you have monolithic application, so all the business logic and everything will be in one application, so one container. It's hard to scale, right? So I mean, but let's say if you want to like increase, or if you want to like add multiple instances of the applications, difficult. But in this case, if you are running microservices, so since we have like using different small piece of services, and you can simply scale, right? For example, if you take this the picture, you can see, right? So based on your requirement, based on your load, you can actually increase, right? You can either scale up or down based on your requirement. And also you can, the important part is you can scale independently without impacting rest of the components. And the second one is risk reductions, right? So for example, let's say so if you want to like update or update and deploy only a part of that microservice, only part of the applications, you can do that without impacting your entire system, right? That is also one of the benefits you can achieve in microservices architecture. So you don't want to like if you have any, let's say you're running as a payment service, and you want to basically update only that particular service, you can do that without impacting other services, because all these are the services are running independently. And also resilient. So let's say if one part of the application, maybe one service is down, but still you can run entire system based on the criticality of the service, so you can still up and running your entire system without impacting the other like other services, right? So if this particular service goes down, it won't like impact to other services. Still you can serve, maybe some part of the applications or some part of the service might not work due to this particular service, but still you can serve your end users with the available the resources and capabilities. And agility. So basically, next point is agility. In microservices, since we are like basically since we are like broken in entire application into different microservices, so you can still run develop these microservices in different what you call different sprints, for example, in agile. So for example, let's say if this particular service it's a small one, and then so you can actually simply deliver this service fast, and these basically services are complex, so can still deliver slower than these services. I mean, since we are like working all these are independently, so if there's no interchange or independent, I mean, there's no independent services, so then you can basically develop all these services simultaneously. That is called agility, and also flexibility. So one nice thing actually microservices provide us, give us is flexibility, because you can, as you can see, you can develop several services in maybe Java, and another set in Node, and maybe another set in different technologies and tools and technologies. You have the freedom, right? That is one nice thing we have in microservices. You can use different technologies and platforms based on your skills and your competency. And this is a sample architecture of a microservice. As you can see, change my point. Yeah. So as you can see, so we have several microservices. See, so here we have like you can see 4 microservices running, and so in front of microservices we have something called API gateway. So and API gateway is basically the entry point, as you can see. So this is your client. So client will hit API gateway first, and so this actually this is a kind of entry point to your microservices, right? So and also you can see identify provider basis. This is used to used for basically authentication and authorization, and also you can see one important component here, service discovery. So service discovery is a place where all the services get registered, and if let's say if clients send a request to API gateway, then API gateway will try to basically identify the relevant microservices from the service discovery, because service discovery, the one who actually maintain all these registries, right? Based on the what you call URL pattern and all that, it can actually identify, okay, this request need to be go to this service, right? And also in Microservice you can still deal with external services. So in this case, I just as you can see, this remote service, you can still actually Microservice can still interact with external services, external remote services as well. And this is basically a very simple microservice architecture, and these are the key components you can find in microservice architecture. So management is basically to manage your microservices, and also static content. CDN basically just to serve static content. And yeah, and so moving on, in every case we have pros and cons, right? Even in microservices also we have disadvantages, right? And so as you can see, so I just listed a few disadvantages here. So first one is communication, right? It's communication in between basically the services is too complex. Let's assume so you have in a monolithic application, everything will be in one single container, one single application, right? So then if you want to communicate with different companies, easy, but in this case it's service to service, right? So let's say if you want to communicate this service, basically communicate this service to this service, it be right through API, right? So you don't have luxury to directly call the functionality of this service, right? So again, every time you have to go through REST APIs with complex, and also more resources equals more services equals more resources, like, right? For example, so since you're having different services, so you need to deploy these services in different environments, right? In that case, you need a lot of maybe VMs, right? Or the servers, right? So because you need infra, right? But let's assume in monolithic application, so all the applications logic, all these functionalities, if it is in one single applications, I mean, less resources, right? So you can simply deploy that in that monolithic application, a single container, single VM. But in this case, since you are like, using different services, you have break that into different small services. So you have to like deploy these services in different VMs, different infra. So it again, I mean, it's costly, right? So you need more resources, and as well as global testing is a bit difficult. Like, so basically, if you want to like test some functionality here, it's a bit difficult, right? Rather than having everything in if you compare to monolithic application. So since you have application like though all the functionalities is in single applications, it's a bit easy. But here, bit difficult because it might impact involving different services, right? For example, let's say you service if you are like trying to test one functionality, it might go through service A and service B likewise. So you have to like test, right, all these scenarios, and all this you have to deal with all these services. It's a bit difficult when compared to monolithic. But and also same debugging, right? So if you want to debug some issues in the application, it's a bit difficult, right? So you have to like deal with a lot of log files, right? Several log files, right? It's a bit difficult, and also deployment challenges, right? In simple terms, like if you have one monolithic application, it's a matter of like simply you get the WO file and deploy. But in this case, so you have to like several services. You have to deploy and build and deploy several services. Bit, I mean, not hard, but it's challenging, right? And also microservice actually it's good for large companies, right? So if you are running small companies, and it's because it's costly, right? So you have to like basically maintain several VMs, right? Maintain several what do you call them? I mean, um, since you need more resources, it's bit costly. So it's good for large companies. Those are the key disadvantages. But and so if you want to use basically microservices, if you want to use Spring Boot in microservices architecture, these are the possible areas you can use Spring Boot. So obviously you can actually use Spring Boot in identity provider, where you implement your authentication and authorization. And also you can use API gateway. I mean, you can implement API gateway using Spring framework, Spring Cloud, Cloud Gateway. And also obviously you can use Spring in these microservices, and also service discovery and management, right? So these are the places we can use Spring in microservices architecture. Okay, so now I'm going to actually show you simple microservices that I have developed. Okay, so this is my simple microservice. I hope you can see, right? This is I'm using actually Eclipse as my ID, and this is actually Project Explorer. And as you can see, I have a single entity called employee. So this employee has only 3 attributes: ID, name, and salary. Okay, and also I have created a repository to deal with data related operations, and that is employee repository. And I have a service. Okay, this is my service. I have actually added several operations, and as you can see, like save employee, fetch all employees, and get employee by ID, and update employee by ID. Likewise, I have added several functionalities, business logic into my service layer. And so I have this controller. Okay, that is employee control. It's a REST controller. It's a this post, I have post endpoint to save employee detail, and as well as get endpoint to get to retrieve actually a list of employees, as well as so you can actually retrieve employee by giving a passing ID, and also you can I have added put method to update employee details, and as well as to delete employee, right? So these are the endpoints that I have added in my controller, the microservice, and so, and also I have create a simple table in MySQL. This is a client, MySQL client I'm using called AD. So here you can see this is my table. So since I have only 3 attributes in entity, so I added 3 fields here. So ID, name is Baj, and salary is in float. Okay. So my microservices actually I have started in, and it's running. Okay. And so I just want to show you like yeah. So basically, as you can see, I'm using Postman because this particular microservice I haven't developed any front end. So this is purely based on REST service, based on REST endpoints. So I'm going to test, I'm going to execute these endpoints, hit these endpoints using my Postman. Postman is a client I'm going to use here. So this is my I'm trying to actually hit the post endpoint. This one, my controller. Yeah, so I'm trying to actually hit this endpoint. Okay, and this is my payload, right? Since I'm going to create a new employee, I'm not passing any ID because its ID is a auto generated one in my entity. So this is auto generated one, right? And I'm just putting only a name and salary. I just put name as John, salary 1,000, and so here this is the yeah. So I have 2 records currently in my table, right? Employee table. So I'm going to execute this one. Okay. Yes, got executed, and then you can see status 200. Okay. Basically, executed this successfully without any issues, and then this is the response I got. Okay. And so if you go here, you can see, right? See, you can see here saving employee, right? And I'm just printing the data, right? This is, I just want to show you here basically the logs. So I have enabled logs. We discussed, right? So in observability, we can actually monitor, right? We can observe application through logs, or maybe enabling matrices, right? So here I have actually added several logs line because I want to observe, like monitor this application through log files, right? There is one use case I want to achieve. Okay, I have added several logs lines here. See, these are the log lines I have added to my application, right? So see, this is what you can see, right, in my console. Okay, and if I go to database to refresh, you can see newly added record. Yeah, you can see that is one part, observability, using application logs, right? So and also I want to show you let's say if you want to monitor this microservice, right? Maybe so you want to basically extract matrices, for example, CPU usage, right? And maybe memory. So those are called matrices. So actually, since we are using Spring Boot, you can use predefined libraries. In Spring Framework, we have something called actuator. So if you want to enable, like if you want to basically monitor, matrices of this microservices, you need to add these dependencies. You need to enable actuator, right? And as well as we are actually trying to, basically show matrices on Prometheus. So we will discuss that in later, but hope you remember our diagram, right? I just highlighted. So we are going to use several monitoring tool. Prometheus is one of them, and also we are going to use ELK stack, ELK, and right. So here we are trying to actually use Prometheus to monitor matrices. So in that case, I have just added Prometheus dependency as well into my microservice application. So once you have like added these two dependencies, so you need to enable, enables few configurations. So like, for example, you need to define the base path for actuator, and also you need to define what are the basically the matrices, what type of matrices you need to enable. Likewise, you need to add few configurations into your application. So once you have added all these configurations, so you can actually go to you can see what are the possible matrices that like endpoints available to monitor this application, right? I'm trying to actually hit this actuate endpoint. It's the get one. Okay, and so here you can see I got several endpoints, right? So as you can see, like, you can monitor caches, beans. There are several, health, several endpoints you can use to monitor this application. So I'm going to actually show you one endpoint called Prometheus. So I'm going to click here. Okay. So I'm going to hit this endpoint, actually Prometheus endpoint. So in Prometheus endpoint, actually, you can see, right, there are several matrices you can find, right? Yeah. Let me copy that into Notepad. Yeah. See, so search some word, let's say memory. See JVM stat, right? You can find, you can see, right? So how many basically lot of like JVM stats available. As you can see, how many threads, right? Live threads count, and also this sorry, threads expirations, and then JVM memory. Yeah. So many, see, you can see, right? So many matrices available, right? So through this APIs, actually, you can monitor your microservices, right? And this is how you need to actually, you can achieve observability in microservices using this Prometheus endpoint. Okay, and this is a very simple one, just to demonstrate the capabilities, and just to give kind of a high-level idea. And any questions before I move into slide deck? Just to summarize, so I just demonstrated two aspects. One is log. So observability using application logs, how to basically enable logs, and how to monitor, like, I mean, the approach to monitor your application through logs, and as well as matrices, right? So this is how you need to enable logs and what you call matrices in your Spring application. But we will basically demonstrate like how to like integrate these with monitoring application in maybe during next couple of sessions, but this is a kind of a basic idea, just to give a basic idea how to the possible ways of implementing observability in your microservice application. Okay. And so okay, so so we are expecting you to create a develop a simple microservice application using Spring Boot, and then enable observability like log plus matrices, right? So as a exercise for this week, we are expecting you to create develop a simple microservice, and so I will share. I have already hosted this the application that I have created in GitHub. So we'll share the repository URL. If you want, you can actually use that as well. But if you are planning to use that, just to make sure go through each and every piece and try to understand, and maybe you can do changes and try it out different scenarios. Yeah, that's about it. Actually, microservice architecture and so how to enable observability in microservices. Any questions, team? Okay, so if you don't have any questions, I think we are done, Indika.
Okay, I think then we can close. So we can close the session. Any question, anyone? I think then we will close the session, Kapil.
Sure, Indika.
Sure. Thanks, everyone.
Thanks, everyone.
Thank you. Thank you, Kapil. Thank you, everyone. Good night.
Thank you very much, sir.
Thank you, team.